Hello students, welcome to Microprocessor lecture series. Today we discuss about status and control signals of 8085 microprocessor. So the first our status signal is S0 and S1. The S0 and S1 are called status signals and the pin number of S0 S1 is 29 and 33 at the microprocessor pin diagram. So S0 and S1 is basically tells the current operation position which is progress in 8085. If the value of S0 S1 is 00, so at that time microprocessor at hold position, microprocessor do nothing any operation. If S0 or S1 is 0 and S1 is 1, means microprocessor write the data to input output block and maybe in memory. If S0 and S1 the value is 10, the data is fetched from memory or input output. If the value of S0 or S1 are both 1, that means the microprocessor fetch the opcode from the memory. Next one is input output and memory bar signal. This pin this pin tells whether the input output or memory operation is being performed. This is also the status signal that shows if input output memory bar equal to 1, that means the microprocessor perform input output operation. Otherwise the signal is 0, then microprocessor perform memory operation and the signal pin is 34 at microprocessor 8085. 3. If we combine the operation with S0 S1 together with input output memory bar, it means if we are having the input output memory bar equal to 1, that means and S0 S1 is equal to 0 and 1, that means it doing the right operation, but at the input output port, means we are already having input output oblique memory bar equal to 1, that means the operation performed on the point of input output port, otherwise memory operation. So we can say the all of status signal together in this table. If the input output block is 0, that means all the operation performed on memory. At the position of at the position of opcode phase, obviously opcode is present on memory, so at this time input output oblique memory bar equal to 0. At this position the value of S0 S1 equal to 1. If we read the data from memory, the input output should be 0 and S0 1 or S1 is 0. If we write data something on memory, means input output equal to 0 and S0 equal to 0 and S1 equal to 1. If input output read, then the value here is obviously 1 for input output operation and S0 equal to 1, S1 equal to 0. Similarly, if we are going for writing operation on input output port, so input output should be 1 and the S0 equal to 0, S1 equal to 1. For interrupt acknowledgement, the all of the signal 1 should be 1 and hold position the input output should be high impedance and there is no any value for S0 S1, there is no affecting for the operation. Now we are talking about the signal which are the control signal of 8085. So basically we are having three types of the control signal. The control signal lines are commonly known as control bus also. So we discuss about the individual signal. Here ALE first one signal. The ALE means address latch enable is one special type of control signal. It is used to latch the address generated during earlier part of execution of any instruction. It is positive going plus generated every time 8085 microprocessor begins an execution. It indicates the bits on multiplexed address oblique data or address bits. So at this position, ALE, if ALE equal to 1, that means ALE behaves like the address behave like as address bus. The present on address bus is called address. If ALE equal to 0, that means the present on the lower order address, the present is data. Add the ALE present in at pin number 30. Next is RD bar. The read control signal is used to control the reading operation of the microprocessor. This is active low signal, meaning that after RD bar signal goes low, the external device plays the data and on the data bus, and microprocessor this reads the data from the data bus. It is important to note that if the data is not present on data bus, RD bar is low. Microprocessor read whatever is available within, which is maybe garbage. At this position, RD bar for read operation, RD bar should be active low signal for read operation, and the present here is the pin number is 32. Next one is WR bar. The write control signal is similar to read control signal. It is also active low signal. The microprocessor places the data on the data bus and makes WR bar signal low. This is responsible to external device that when our WR bar signal goes low, it should be read data from the data bus. So the signal is also active low signal. So in this lecture we study about all the signals which are the control signals and which are the status signal. Thank you.